පුතමා මාව ඇහෙනවද? Okay. 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 Let's start now. Can you hear me? Can you hear me? Okay. Okay. Today I'm going to discuss this worksheet first. Can you take it? And I'm going to discuss it. That one, huh? Functions, and that include functions and logarithms and exponentials. Functions, logarithms, and exponentials. Okay. First, move to question number 1. Question number 1. Take this one. Question number 1, first part. Here we have to find domain and the range of the following functions. Domain and the range of the following functions. So last day I introduced domain and range. So when finding domain, we have to think about possible x values. But here functions are given with different variables. So first one, here ft equal 2t plus 1. Here this is input variable. Here output variable. Then possible value of t, here domain is the real set. Then corresponding y value, that is range, again that also real set. That also real set. Check your answers, okay? Then second one, here gx equal 3x square minus 5. So we know for any polynomial, domain is the real set. Then here domain is the real set. And range, here 3x square minus 5. Here you have to subject x, no? You take here y. Then here y plus 5 divided by 3 root x. Here x value, plus or minus. Here this is x value. Therefore, when finding range, we have to subject x values. We have to subject x values. Then you check possible values of y. Possible values of y. If you have any doubt, just drop me a message, okay? Then here within square root value must be positive. Then y plus 5 greater than or equal 0. Then y greater than or equal minus 5. This is our range. Therefore, here you can write range y element of real set y such that y greater than or equal minus 5. Here, second one, range. Then third one, here hy equal 3 over 2y minus 1. Here this is input variable now. Then variable can be different. No? Usually we write y equal fx. Y equal fx. Then x mean independent variable, y mean dependent variable. But here, somewhat different. No? Then you take here input value. Therefore, domain. So we have rational type. No? Then by the real set, you subtract denominator 0. Then range. So when finding range, you have to subject. Here, first you take t. Then you have to think about t values. Then here, 2y minus 1 equal 3 divided by t. Y equal 3 divided by t plus 1. Again divide by 2. Then you have to think about possible t values. No? Possible t values. Therefore, range here we can't get 0 value. Then real value without 0. Here the range. So remember, when finding domain, you have to you have to think about input values. When you find in range, you have to think about output values. Then to find output values, you subject x and think with 3 conditions. That is, no denominator 0 is possible, within square root, non-negative, within logarithms, always positive. That is question number 3. Okay, check your answers. Then question number 4. Here fx given 2x over 3 minus 1 plus 1. Here this is polynomial linear type. Therefore, domain is the real set. Then range, for any linear function, range is the real set again. You can subject x, then no restriction can occur there. Then here again real set. So you take here y, subject x, then y minus 1 times 3 divided by 2, that is x. Then here all y values are possible. Then range is the real set. That is question number 4. Okay. Then if you have any doubt, you just do with me. Now go to question number 5. Here function alpha theta 2 theta minus 1 divided by 5. 2 theta minus 1 divided by 5. Then you don't worry about input variables and output variables. Don't worry about that. First you identify, here subjected one as the dependent variable, then the other side variable as the independent variable. Therefore, here theta, we don't have any restriction. Therefore, domain is the real set. Then range, That is, then possible y values. When you subject theta, we don't have any restriction, again real set. So here range. So anyway, you remember for polynomial functions, domain always the real set. Domain is always the real set. Then if you have rational one, you have to remove denominator zeros. If you have irrational one, you have to remove denominator within square root negative values. If you have logarithmic function, then you have to remove within logarithms negative values and zeros. Okay. Here question number 1. Okay. Just complete it and check your answers. Complete. Let's move to question number 2. Let's move to question number 2. If you have any doubt, just ask me. Okay. Now let's move to question number 2. So in which equation it despite that x and y are functions. So we have to identify whether it is function or not. So you remember, if we have y equal fx kind of thing, y equal fx kind of thing, we say that is a function. Y equal fx kind of thing, we say that is a function. Then remember, y to the power 1 expressions must be a function. If we have y to the power 2, y to the power 3, y to the power 4 expressions, you don't say that is a function. That is a function. Then definitely it y to the power 1 must be there. Y to the power 1 must be there. Then y equal 3x square minus 1, y equal 1 minus 2x, y equal x squared, y equal 2x, y squared equal 2x, then x squared plus y squared equal 4, y equal 3 of x, y squared equal 1 minus x. Let's check them. Let's check them. So if we have y square relations, you don't say that is a function. Usually we can say y is a function of x. No? So when you consider y is a function of x, y is a function of x, then y square impossible. Then this is function. No? This is function. Here y to the power 1, y to the power 1 function. Here y square, not a function. Then here we y square, not a function. Here y function. Here y square, not a function. No? That's how we identify. If y is a function of x, if y is a function of x, then y can be subjected easily. Then here y to the power 1 relations are possible with the functions. So there's another thing. Here y is a function of x. Likewise, there can be x is a function of y. So you think again, here x is a function of y. So here y to the power 1 relation. Here this will be x to the power 1 relation. That will be x to the power 1 relation. Okay. See, that must be x to the power 1 relation. Okay. Now, here I'm going to find whether x is a function of x. Here y is a function of x. Here x is a function of y. So here y to the power 1, here this must be y to the power 1 relation, x to the power 1 relation. This is not a function. Here x to the power 1 function. Here not x to the power 1. Here x to the power 1. Here no x to the power 1. Here we have x to the power 1. You can subject x, no? Then here we have x to the power 1. So that's how we identify. Then if y is a function of x, then there must be y to the power 1 relation. If x is a function of y, there must be x to the power 1 relation, x to the power 1 relation. That's how we identify whether it is a function. Okay, check and complete. That is question number 2. question number 2. Okay. Now let's move to question number 3. Now, let's move to question number 3. If you have any doubt, just ask me. So let's see question number 3. Here we have to find images. We have to find images. So question number 3. Here fx x square minus x plus 1. X square minus x plus 1. No? Now f minus 1 means you have to replace x by minus 1. Then simplify, we get answer 3. Then f0, substitute x equals 0. Substitute 1. 1 square minus 1 plus 1. Here 1. fh, h squared minus h plus 1. f x plus h. So replace x by x plus h. Replace x by x plus h. Then x square 2xh, h squared minus x minus h plus 1. Okay. Then final one, f x plus h minus fx divided by h. So we know fx plus h and we know fx. Then you substitute then, no? You substitute. Then here x squared 2xh h squared minus x minus h plus 1. Here this one. Minus fx. Fx means here this one. X squared minus x plus 1. Now then divide by h. Now just simplify. You can cancel x square term. Again, we can cancel x term. Again, we can cancel 1. 1. Then final answer. Here 2xh minus h. Then further we can cancel h, no? We can cancel h. Then 2x plus 1h here minus 1. Here it is. Okay. By each term, here we have remaining 1, 2, 3 terms. By each term, you cancel h with this. Cancel h, then 2x. Cancel h, that is h. Then cancel h, that will be minus 1. That is question number 3. That is question number 3. Okay. Check it. Check it. Okay, some of these questions are somewhat hard, but don't worry about that. You try. You take time and you try to do it, and later we can claim all. But anyway, you just try. Try is the most important thing. Okay. Okay, that is question number 3. Okay. Now then let's move to question number 4. Let's move to question number 4. Okay. Now here question number 4. Here we have fx, x squared plus 4x plus 1, and gx, 2x plus 1. Here we have to get a function of a function. So that represent fgx and gfx. Then fgx. So here we have function x. Then instead of this x, you put gx. Instead of x, you put gx. Then here gx squared 4 times gx plus 1. No? So here fgx means instead of x, you have to put gx. Now again, we know gx, that is 2x plus 1. Then replace here 2x plus 1 here. Gx means 2x plus 1, put it here. For 2x plus 1, here plus 1. Now simplify. Here we have just expansion, no? Expand, this is binomial. Here 4x squared plus 4x plus 1, this binomial expansion 4x squared, 4x plus 1. Here 8x plus 4 plus 1. Then final one, 4x squared, 12x, 4x squared, 12x, 4, 5, 6. Here is. That is fgx. That is again important thing. So if gx means function of function, we need to put gx function inside to fx. Okay, that is fgx. Then gfx, similar thing. The gx now. So inside that you have to put fx. Then instead of x you put fx. Then 2fx plus 1. Fx is this x squared plus 4x plus 1 plus 1. Here it is. Okay, then you simplify 2x squared plus 8x plus 2 plus 1, 3. Here it is. That is fgx and gfx. Then same thing we can denote this one f o g x. Here we can denote g o f x. We call that is function of a function. We call that is function of a function. That is question number 4. Complete. If you have any doubt, just ask me. If you need to further explain, you just drop me a message and continue. Okay. Now, again, let's move to question number 5. Sorry, question number 5. Okay, check it now. Now here, question number 5. Fy equal y squared. Gy 1 over 1 minus y. So we have to find gy squared. Gy squared. Don't worry about the variables, okay? Then usually we discuss the things with variable x, independent variable x. But here, independent variable y, no? Independent variable y. Don't worry about thing, but you identify the idea of the notation. Here, gy square mean replace y by y square, replace y by y square. Then here y, no? Replace by y square. So again, y square mean that is fy, no? And here 1 minus fy. This is it. Then here left hand side gy square. Then here now equal to right hand side. You can prove that one like an identity. So you just think about that variable change. Here gy given, need gy square. Then by this one you can derive this. Then here you replace y by y square. No? Replace y by y square. Then you can take the result. That is question number 5. Take time. Complete. Okay. Then question number 6. Again, we have to write domain. Question number 6, again, we have to write domain. Then domain means possible x values now. Then you have to think about possible x values. Okay, let's do. Question number 6. First function fx, x square plus 1, fx 1 over x square minus 1. So this is polynomial 1. Therefore, domain is the real set. Here, this is rational 1. You factorize denominator first, x minus 1, x plus 1. So at the beginning, you have to factorize the expression. So if you have denominator, definitely you have to think about denominator factors. Then you neglect denominator zeros. You remove denominator zeros. Then here domain, usually real value, we have to remove denominator zeros, minus 1 and 1. No? You have to remove that. That is 2. Then 3, fx. Here 1, 2, 3. You check all the answers with me. Then third one, fx equal 2x plus 1 over x square plus 1. X square plus 1. Here again, rational type. But the thing is, here we have denominator. No? That is always positive value, no zeros. X square plus 1, we don't have any zero value. Therefore, no need to worry about this denominator. Then you say domain, just real set. No? That is 3. Then fourth one, fx equal root x. Now here we have to think. So we have irrational relation. So we know when we have irrational relation, we have to remove within the square root negative values. Then here domain Yeah, x greater than or equal 0. You can write this one as positive real value with 0. This notation possible. Positive real value with 0. No? X values are possible greater than or equal 0. No? Then here the domain. That is question number 4. Which question, Puta? Y3 real only? Third one, no? This one, no? Okay. Now here, this is rational, no? This is rational. Usually we remove denominator zeros, no? But x square plus 1 always positive. We don't have any zero value here for denominator. X square plus 1. We don't have factor. We can't write any factor, okay? If we have x square minus 1, then we have factor here. That is x minus 1, x plus 1, no? X minus 1, x plus 1 factors. But for this case, we don't have any factors. Here, x square minus 1, x minus 1, x plus 1. X square plus 1, we don't have factors. No factors. Then no denominator zeros. No denominator zeros. Then that's why we write here, domain is the real set. Domain is the real set. Did you get it? Okay. Just complete that. Okay. Now fifth one. Fifth one. Here fifth. Here function given root x plus x minus 1 root plus x minus 2 root. Okay, we have three rational functions addition. We have three rational function addition. So when you have this type of irrational functions, you have to think about within square root non-negative values. No? Therefore, here for this x greater than or equal 0, here for this x greater than or equal 1, here for this x greater than or equal 2, you have to think all. Then let's here greater than or equal 0. Then here greater than or equal 1. Then greater than or equal 2. Then common region greater than or equal to. Then domain here, x real value, x such that x greater than or equal to. Here the domain now. That is question number 5. That is question number 5. Complete? Then question number 6. Fx equal x minus 1 root of x minus 2. Now here it is combined function, no? That is combined two functions. Here irrational one, here we have fully rational, and within that we have irrational one. So we have to remove denominator zeros. Here you have to remove denominator zeros. That means x not equal to. And within logarithms, values must be positive. X greater than or equal 1, no? X greater than or equal 1. Therefore, finally, x greater than or equal 1, but you have to exclude 2. You have to exclude 2. Therefore, here domain x any real value x such that x greater than or equal 1, but x not equal to. You have to remove 2, no? You have to remove 2. So that is the domain. You have to think about within square root values, then within square root values, non-negative and no denominator zeros possible. Both you have to think because that is given in single function. Then you have to think about both. That is question number 6. Here we have to remove x equal 2 value, we have to remove. Complete. Okay, if you have trouble, just let me know. Okay, let's move further. Let's move further. Now take this. So seventh one, sorry, yeah, seventh one. Here fx equal 1 over x square minus 5x plus 6. So if we have denominators, we have to do that very carefully. So here we have denominator, no? Then you factorize denominator. So we have two factors, x3, 2, minus, minus. Likewise, we have denominator factors. Then you remove those denominator zeros. Therefore, domain, real value, remove 2 and 3. Then eighth one. So here we have fx equal 1 over x squared plus 1. Here this is rational, but x squared plus 1 always positive. X squared plus 1 always positive. We can't get any zero value for this. Therefore, here domain is the real set again. Domain is the real set again. No? That is question number 8. Okay. Check your answers. Okay. Then question number 9. Let's do that. Question number 9. Fx equal 1 plus x over x square minus 5x plus 6. So here you factorize x3, 2, minus, minus. Then domain, real value, you remove denominator zeros. Don't worry about numerators, no? Then you just think about denominator zeros and you just eliminate that. Then 10th one, check your answers. Fx equal 1 over x square minus 5x. So if you have rational functions, definitely you have to factorize denominator. Definitely you have to factorize denominator. Then take x outside. Here x minus 5. Now we can see factors. No? Then domain, usually real set, and remove 0 and 5. Here it is. You remove 0 and 5. That's how we get it. That is question number 10. Do with me. Then question number 11. 11. Here fx equal x square minus 16 root. X square minus 16 root. So we have here irrational relation. So when we have irrational relation, you have to remove denominator within square root negative values. Therefore, when you have to evaluate this inequality, you have to evaluate that inequality. That is, Factorize first. X minus 4, x plus 4. No? Then here we have zeros here. Minus 4, 4. Then value greater than 4. Value greater than 4. Here definitely this. Here positive and here positive. All will be positive. Positive. Then value less than minus 4 for this region. Take minus 5, then minus 9. Here minus into minus plus. Then for this region plus, for this region plus. But for this region, minus 4 to 4, take 0, put it here. Then minus 4 times plus 4, that is negative. Then here, greater than 4, less than minus 4, that expression will be positive. But in between minus 4 to plus 4, then the expression is negative. Therefore, domain x real value, x such that x less than minus 4 equal union x greater than or equal 4. Here, domain. If you have doubt, let me know. So we have to think that inequality, that is really important. So here, x square minus 16 greater than or equal 0. This is specially we call quadratic inequality. So under inequality lesson, we're going to discuss linear inequalities, quadratic inequalities, any polynomial type inequality, rational type inequalities, and so on. We have to think, discuss many things. But for now, using general idea, you evaluate that inequality. You have to evaluate that inequality, okay? That is 11th one. Then 12th one, here fx x minus 1 modulus, x minus 2 modulus. You don't worry about modulus. So we have to think about, if we have denominators, we have to remove denominator zeros. If we have square root, then we have to take only positive or zero values within square root. If we have logarithms, we have to take only positive values inside the logarithm. Then for modulus, we don't have any restriction. So you can put any real value for x. Here, say domain is the real set. Domain is the real set. Okay. Complete. Okay. Now, let's move to question number 7. So find the range of the following functions. Find the range of the following functions. So range means possible y values. Then find in range. For now, we can do that one by subjecting x. By subjecting x. Let's do that way. Let's do that way. Or otherwise, we can do this find in range case by sketching the graph. So when you sketch the graph, we can identify its range again. We can identify domain and as well as its range. Okay, let's see. Question number 7. Question number 7. So here fx equal x plus 2. Then y equal x plus 2 now. So when find in range, you have to subject x. X value equal y minus 2. Then y any value possible. Therefore range is the real set. Or otherwise you can do this way. Here x-axis, y-axis, y equal x plus 2. Here the graph. That's the graph. Then you think about possible y values. Here, see, all y values are possible. No? Then without any restriction, all y values are possible. Therefore, range is the real set. Again, by the graph, we can get the range. Then second one, y equal modulus x. So let's do this way. modulus x. Then here we need to sketch the function. Then range mean possible y values. So we know how to sketch modulus function. Here x-axis, y-axis. The graph look like this V-shaped graph. No? Here no negative y values possible. Then here positive y values all are possible. Here see. Therefore here range all positive y values and 0 again possible. Here the range. These are important things. You have to think about possible y values. Okay. So if you can sketch the graph, then you sketch the graph and think about possible y values. That is range. Okay. Then don't worry about third and fourth part. Later we will discuss that. That comes with sine, tan, with trigonometry. Then don't worry about that part. Just forget that one, but don't cut it. You just forget it for now. So later we will discuss range of tan and range of sine. For now, you just forget it. For now you just write solution sine range -1 to +1, -1 to +1 range. Here the range. Tan range -∞ to +∞. Don't worry about this part. Okay. So within square bracket we write that. So this is open bracket, infinity open bracket, here open bracket. For now you just write solution. Don't worry about how it is happen. Don't worry about how it is happen, because later we have discussed about many things about trigonometry. Then we discuss all the things there. For now, you don't get any this type of ranges in our term test. Okay, don't worry about that part. No? Complete. Okay. Now let's move further a little. Okay, then fifth one. So y equal root x. Then you subject x. Then x equal y squared. X equal y squared. Then x equal y squared. And we know how to sketch root x, no? Yeah, x-axis, y-axis. So it looked like this root x graph. X equal y square here, the function, but y equal root x graph is this. Root x graph is this. Therefore, positive y values only possible. Therefore, range positive real value is 0. Just get the idea, okay? So when finding range, we better to remember sketching graph. But we can do few sketching graph. We can do only few functions. But later we will discuss many more functions, how to sketch graph. But for now, you just remember y equal x, linear functions, and just modulus functions, and just reciprocals, and quadratic functions. You have to remember those. Then y equal just root x. We know how to sketch those functions now. Then you have to remember about that. Then anyway, you think domain mean possible x values, range mean possible y values. Usually when we have a function given, you subject x, then check possible y values. But these cases, some are difficult to find that way. Okay, then that's why we sketch the function. Then sixth one, y equal 2 to the power x. Okay, this is very special. Okay, so here see the graph. Here see the graph. Okay, y equal 2 to the power x. Let's sketch it. So if you need to if you have need to get range, you better to sketch the function. Then by the graph, we can discuss everything. We can discuss everything. Okay. Here put x equals 0 here. When x 0, 2 to the power 0, 1. Then that passes through 1. When x equals 1, 2 to the power 1, 2. When x equals 2, 2 to the power 2, 4. When x equals minus 1, 2 to the power minus 1, 1 over 2, half. Then it goes like this. Here y equal 2 to the power x function graph. 2 to the power x function graph. Okay. Then here range possible y values. Here all y values are possible, but y0 and y negative impossible. Then positive real value only possible with the function. Positive real value only possible with the function. If you have any doubt, let me know. I can explain more than this. So you just try to sketch function, then you think what are the possibilities of y, then write the corresponding set, and that will be the range. Complete. So I think these are somewhat new to you, but anyway, you get that idea first. Range means possible y values. We have to think about range. That means we have to think about possible y values. Then when finding range, we better to sketch the function. So if the function too difficult, then we better to sketch the function. Then without just algebraic relation, we can't say the range. Okay, complete. Now, again, we have here for the two functions. So let's find them. So here next function, seventh one, y equal x of x minus 1. X of x minus 1. Then subject x, cross multiply, xy minus y equal x. Then xy minus x equal y. Then take x outside, y minus 1, y. Then x equal y over y minus 1. Then when finding range, you have to remove denominator 0. No? Then y equal 1, you have to remove. Then real value without 1 is the range. Real value without 1 is the range. Then eighth one, y equal x minus 1 over x plus 1. Then cross multiply. Then subject x. You put 1 here. Then x minus xy equal y plus 1. Take x outside, 1 minus y. Then subject x, y plus 1 over 1 minus y. Then range, usually real set, here remove 1. Then here the range. That's how we obtain range. Therefore, when finding range, in some cases, we can easily find range by subjecting x. Then you think about possible y values. But for some advanced cases, you have to sketch the function, then think possible y values by the graph. Okay, by the graph, we can find range. Complete. Now, that is question number 7. Then find in range. You can do, you have capacity to do, that means when finding range, you have some capacity. That means all the cases you can't find ranges, because we have to discuss many things under functions again and again later. Okay, then this skill may develop later, but anyway you just identify domain mean possible x values, range mean corresponding y values. When finding range, you subject x, then check possible y values. Okay, so on you have to think. But some cases, using that relation, we can't find range. In such case, we better to sketch the graph. Then we have to think about possible y values. Okay. Okay, that is question number 7. Okay, now let's move to question number 8. Okay, question number 8. Take this. Y equal fx. So that is given ax plus b divided by cx minus a. Cx minus a. So we have to get x equal fi. We have to show x equals fy. X equals fy. Then here y equal ax plus b over cx minus a, no? Cx minus a. Then fy mean, here fy mean ay plus b over cy minus a, no? That is fy. So by this you subject x, cxy minus ay equal ax plus b. Then take this here, cxi minus ax, put this here, ay plus b. Take x outside, cy minus a, ay plus b. Then subject x, ay plus b over cy minus a. Ay plus b of cy minus a, that is fy. Then x mean fy. So we have to think about notations, okay? We have to think about notations. Here fx equal ax plus b over cx minus a. Then fy mean, here this is fx, then you replace x by y. Then here instead of x you put y. Then here the relation, that is fy. So here we have to subject x. We have to show x equals fy, no? Then by this relation, you try to subject x, cross multiply, simplify, and subject x. Here it is. Then here this thing we know that is fy. We can put there, no? Okay, complete. Sometimes these questions are advanced for you, but anyway, when you are practicing all, then these will be very special, very simple question. But anyway, you have to practice again and again. You have to practice again and again. Then these questions again you do, later you do again, okay? That is question number 8. Now let's move to question number 9. Question number 9. Okay, if you have any doubt, ask me. So these are somewhat advanced type questions. You have to think and you have to do. Okay, don't worry about if you can't do, don't worry about that. But anyway, after discussing that, you try again and again. Then you practice that one. Okay. Then question number 9. Fx equal 1 over x plus ax. Fx equal 1 over x plus ax. So here f 1/5 equal 28 over 5. So f 1/5 mean you have to replace x by 1/5, no? Then here 1 over 1/5, a 1/5, 28 over 5. Then put it here, 5, a over 5, 28 over 5. Then multiply by 5 now, 25 plus a, 28. Then a equal 3. A equal 3. Then a value 3. Okay. Then same time, let's do question number 10. Question number 10. So here fx equal x square plus 1. Fx equal x square plus 1. Show that. Take left hand side. 2f3 minus 1 over f minus 5. You take left hand side and simplify that. Okay, take left hand side and simplify it. Okay. Now we know the function. Then 2 times f3 means substitute 3. F minus 5 means substitute minus 5. Then 2, 9 plus 1, 10. Here 25 plus 1, 26. Then here 20 minus 13, that is 7. Now that equal to right hand side. So you better to prove that one like identity. Better to prove that one like identity. Okay, complete that. Okay. Now, next question. Question number 11. Question number 11. Here fx given log 1 minus x, 1 plus x. Here that is log function. So we have to get fa plus fb. Then take left hand side. fa plus fb. Then fa mean you replace x by a. 1 minus a, 1 plus a. Log 1 minus b, 1 plus b. Then log addition mean product. 1 minus a, 1 plus a. 1 minus b, 1 plus b. So we have to apply logarithmic rules again. So log addition mean log product. Now just expand this. Then log a1 minus a minus b plus ab. So denominator 1 plus a, 1 plus a plus b plus ab. Here, expand numerator and denominator. Expand numerator and denominator. Further, we have to show that if a plus b over 1 plus ab is that. So you take the other one. Other side, right hand side, if a plus b over 1 plus ab. So here this is log function, fx function. Then if a plus b over 1 plus ab mean you have to replace x by this a plus b over 1 plus ab. No? Then put log 1 minus a plus b over 1 plus ab. 1 plus a plus b over 1 plus ab. Then here log, get common denominator, this goes to here. 1 plus ab minus a, here minus common for both, no? Minus b. Here this goes to here. 1 plus ab plus a plus b. Here it is. Now see, they are same, no? Then left hand side equal right hand side. First you have to get that notation idea. First get that notation idea and do simplification. We have to prove identity, no? Then take one side, simplify, and take the other side, simplify. Now both of them are same. Then the identity we can verify, no? Complete. If you can't grab the relation, just ask me, okay? So these are general relations. So with logarithms, that's combined, no? Functions combined with logarithm. Then we have logarithmic function. Then we have to do that notation idea, get notation idea. If a mean replace x by a, if b mean replace x by b, then simplify. Then by that simplification, we have to think about logarithm. Then here, if a plus b over 1 plus ab, then you replace x by a plus b over 1 plus ab, no? Okay, complete. Okay. Now let's move to question number 12. Question number 12. Find the inverse functions of the following functions. Inverse function. So see this. So we know how to find inverse function, no? So you subject x. First you subject x and replace x by y and y by x. That's how you find inverse function. Subject x, replace x by y and y by x. Then question number 12. First one, y equal 2x plus 1. Then subject x, y minus 1 over 2. Then replace x by y. y by x. Then y equal x minus 1 over 2. Y equal x minus 1 over 2. Here function, here inverse function. Second one, y equal 3x minus 5, subject x, y plus 5 over 3. Then replace x by y and y by x. Y equal x plus 5 over 3. Then here inverse function. This is our function. Then very simple relation. Okay. Then third one, y equal 5x plus 7. Then subject x, y minus 7 divided by 5. Then replace x by y and y by x. Y equal x minus 7 over 5. Here f inverse, here function f. Fourth, y equal 1 over x plus 3. Then here 1 over x equal y minus 3 cross multiply. Then 1 over y minus 3 equal x. Then replace x by y and y by x. Then here y equal 1 over x minus 3. Here inverse function. And here the function. 1 over x minus 3. Then fifth one, y equal x plus 1 over x minus 1 cross multiply x, y minus x, y plus 1, get x outside. Then subject x, replace x by y and y by x. Y, x plus 1 over x minus 1. Here, inverse function. Here, function. Function and inverse function. Then we have to subject x first. Okay, complete. Okay. Then last one. See, last one. Here function somewhat hard to subject x. Here function somewhat hard to subject x. Okay, see, here y equal x minus 3 over x plus 2, 1 over x. 1 over x. Okay, so we have to subject x, no? Now here we have x numerator, denominator, and separate term, we have x term. No? So first of all, you try to compress it. So let's do this thing. Get common denominator, x plus 2 times x, cross multiply this way, then again cross multiply. Here xy, x plus 2, here expand x square minus 3x plus x plus 2. Likewise, we just expand. Further you simplify. Okay, further you expand. Okay, further you expand. Then here x squared y, 2xy, x squared minus 2x plus 2. Then put all terms here. Here it is. Now we can see quadratic pattern, no? Then subject x squared. Here y minus 1. Take x outside. To 0. Now this is quadratic format. So by this quadratic format, to subject x, here x to the power 1, x to the power 2, no? Two different formats. Then we have to get complete square method. Complete square method. So later we discuss quadratic functions and equations, more thing under quadratic functions and equations. By using general knowledge, you try to subject x. Try to subject x. This is somewhat hard, okay? So you simplify, take up to this, then we have to subject x by taking complete square. Okay, first you do up to this. First do up to this. Okay, now let's move further. Further we have to simplify this one, okay? Further we have to simplify. Now see, so this case, complete square method. So when you subject, you know ax squared plus bx plus c equals 0, x equal minus b plus or minus b square minus 4ac root divided by 2a. You take this formula, then here subject x minus b, then here x coefficient is the b value, 2y plus 1 minus b plus or minus b squared minus 4ac, a mean y minus 1, c mean minus 2, root divide by 2a. Now y subjected. Okay. Now y is subjected. Sorry, x is subjected. Okay. Then here replace x by y and y by x. Then further you can cancel this common 2 term. Then y equal here y plus 1 plus or minus y plus 1 squared plus 2 times y minus 1 root divide by y minus 1. That is our inverse function. So Here we have plus or minus terms, but you better to take one term. Okay. So for that one, variable x values, that means domain of, as according to domain of x, we have to select one sign, but for now you put that one. So this is the way of subjecting x. Okay, complete it. That is somewhat hard. Okay. Now let's move to logarithm part. Logarithm part. So most of these questions are advanced questions. Okay, these are somewhat advanced questions, but some of them are very easy, but some of them are advanced. Then I'll pick randomly questions. Okay. So first let's move to question number 9. Question number 9, logarithms. Take left hand side, 1 over log a base abc, 1 over log b base abc, 1 over log c base abc. Then take into upstairs log abc base a, log abc base b, log abc base c. So when we take into numerator, we can interchange base and the value. Okay. Then log addition mean product. Log ABC, here write as product, ABC, in same base, same value 1, that equal right hand side. That is question number 9. Then let's move to question number 10. Then here log x over y minus z, log y over z minus x equal log z over x minus y. So same question we have done before when we are doing logarithm, same questions we have done. So when we have two equal signs, you better to put another equal sign with t, no? Better to put another equal sign with t. Then take these two and cross multiply log x t times y minus c. Then take these two. Then log y equal t times cross multiply z minus x, c minus x. Then log z equal log c equal t times x minus 1. Here 1, 2, 3. Okay. Then here we have to get x, y, z, no? Then add them. So take 1 plus 2 plus 3. Then when you add them, log x plus log y plus log c. Here when you add, you can cancel z, you can cancel x, you can cancel y. Then the result will be 0. Result is 0, no? Result is 0. Then log addition, we can write as product log x, y, z 0. 0 result happen when log 1, no? Then log 1, 0. Therefore, say x, y, z, 0. X, y, z equal 1. Therefore, you say x, y, z equal 1. Therefore, x, y, z equal 1. That is question number 10. Question number 10. Okay. Now, let's move to another question. Question number 11. Let's move to question number 11. Take left-hand side 1 over a plus 1, 1 over b plus 1, 1 over c plus 1. Then say same type question we have done before. Then 1 over a mean log x base yz plus 1. 1 over log b mean y base xz plus 1. 1 over log z base xy plus 1. Okay. Then 1 over log x base yz. Instead of this 1, write log x base x. Here log y base xz plus, here instead of 1, right, here we have 1 y base y log z base xy log z base z. Okay. Now here addition, we know we can write as product, no? We have same base x. Here product x, y, z, c. Here same thing. Log y base x, y, z. Here log z base x, y, z. Take into upstairs. Log x, y, z base x. Take into upstairs. Log x, y, z base y. Take into upstairs. Log x, y, z base z. Now addition, write as product. Log x, y, z, x, y, z. And same base, same value, we get 1. Equal right hand side, no? Equal right hand side. That is question number 11. Take time. Okay. Now let's move to question number 4. Let's move to question number 4. So if a square plus b square equals 7ab, we have to show one relation, that is 2 log a plus b over 3 equal log a plus log b, log a plus log b. Okay, see? So if you have any doubt, just let me know. I'm going to question number 4. So here a square plus b square equals 7ab. Then there we have a plus b divided by 3. No? Then you better to add both sides. 2ab. Here 9ab now. Then here purpose square. No? A plus b squared. 9ab. Then a plus b whole thing squared over 9 equal ab. Then a plus b over 3. Now put logarithms. A plus b over 3 to log ab. Now this power we can write at the beginning. 2 log a plus b over 3. Then log addition mean product. Some product mean addition. That's it. Yeah, a plus b over 3, okay? A plus b divided by 3. So that is question number 4. Okay. Now let's move to question number 2. Question number 2. Take this. Log a base b, log b base c, log c base a, here left hand side. Then write log a base b. This one write log c over log b. So here also you can write log b over log a. You can write this one as division of logarithms, common base. Here log a over log c. Then cancel log c, cancel log b, cancel log a. So that is 1 right hand side. Okay. Then question log 5 base 35, 32 into log 4 base 7 into log 7 base 1 to 5. Then here log 5, 32, 2 to the power 5. Log 4 base 7. This is 49, no? Log 7 square 1, here 5 square. Then put this 5, 5. Log 5 base 2, here 4 right 2 squared, okay? Take that power outside by denominator. Log 2 base 7. Here take this 2 again outside, here power 3. Take it outside, 3, and take this 2 in the denominator. Then log 7 base 5. Then log 5 to 2, 7, 7, 5. Here this part you can say 1, no? That is 1. That is 1. Therefore, final answer 15 over 4. We have to find the value. Then here 15 divided by 4 is the value. 15 divided by 4 is the value. That is question number 2. If you have doubt, just let me know. Okay. Okay, now let's move to another question. Let's move to question number 8, exponential equation part. Exponential equation part. Question number 8. First part, root 3 to the power 2x, 3 to the power 7x minus 5. Here, square root, we can write 3 to the power half, no? Then here, 3 to the power 2x divided by 2, no? 7x minus 5. Then 3 to the power x, 3 to the power 7x minus 5. Now equate indices. Then subject x, 5 over 6. 2 log 2 base x minus 2, log 2 base x equal 3, 2 base x minus 2 times x. Here log addition mean product. Then here by exponential subject x minus 2 times x equal 2 to the power 3. Fundamental logarithmic rule. Log 2 base x minus 2, log 2 base x, write as product. Then you can subject this one 2 to the power 3. Then simplify. Here x square minus 2x. Here 8, now put it other side. Now further, we can solve this. We have factors. X for 2 minus plus 0. Then here x value minus 2 or x value 4. X value minus 2, x value 4. So again, I told you previously, when we have logarithmic equation, so we have to think about the solutions. So this minus 2 not satisfied with this equation, no? So if you put minus here, within logarithms, that is negative. Therefore, this is not possible solution. You remove it. But when we get x equals 4, here possible, here possible. Therefore, minus 2 not a solution, but x equal 4 is the solution. That is really important for logarithmic equation. For logarithmic equation. Then third one, log 7 base 3x minus 2 equal log 49 base 49. Then log 7 base 3x minus 2. Then same base, same value 1. Same base, same value 1. Then fundamental theorem subject 3x minus 2. 3x minus 2 equals 7 to the power 1. 7 to the power 1. Then 3x equal 9, x equal 3. X equals 3. So exponentials, logarithms, definitely for your term test, there will be questions. Logarithmic theorem proof again, there can be there. Okay. Then you have to practice logarithmic theorem proof, exponential equations, and logarithmic identities and logarithmic equations. Those are things. Then under logarithmic equations, that is really important. You have to check the solutions. You have to check the solutions. Then these solutions must be verified with original equation. That is the important thing. That is question number 3. Then question number 4. Question number 4. So we have logarithmic equation log half base 2x minus 3 log half base x. Then same base, no? Coefficients 1, you can cancel logarithms by taking antilog. Then x equal 3. X equals 3. Then last one, fifth one, 2 ln x equal ln 2x plus 3. So we know ln mean logarithmic relation, that is log e base. Then first you put these 2 ln x squared ln 2x plus 3, cancel ln, then x squared 2x plus 3. Then get all one side x squared minus 2x minus 3, 0. Then factorize x, 3, 1 minus plus 0, x equal minus 1 or x equal 3. X equals minus 1 or x equals 3. So that is question number 8. Question number 8. Okay, complete it. Okay. Now let's move to question number 6. Question number 6. Check your answers. Question number 6. Here, 2 to the power x minus 5 to the power y equal 3. Yeah, special type of simultaneous equation. Some special type of simultaneous equation. Here 2 to the power x minus 3, 5 to the power y minus 2 equal 21. Then here you better write 2 to the power x divided by 2 to the power 3, 5 to the power y, 5 to the power 2, then 2 to the power x divided by 8, 5 to the power y divided by 25, 21. Okay. Then you better to get substitution 2 to the power x equals, let's say p, and here 5 to the power y equal q. Take p and q. Then here by this relation, here by this one, here p minus q equal 3, say 1. By this relation, here p over 8, q over 25 equal 21. Okay, now we have simultaneous equation. No? Then p equal q plus 3. No? Here second one. P equal q plus 3. Put it here. Here p equal q plus 3. Put this one. Now you can simplify. No? Now simplify. Then you can cross multiply and you can simplify. Cross multiply 25 q plus 3 plus 8q, 8 times 25 times 21. Then 25q, 8q, 33q, 75. 8 times 25 times 21. Don't expand all at once. Then this is divisible by 3. Then 11, 25, 7. Okay. Then here, further you can simplify. No? 11q. Here 56 times 25. Then here you can write 56 times 25 minus 25. 55 times 25. Then divisible by 11. Then here 5. Then q equal 125. Q value 125. Q value 125. That means 5 to the power 3. That means 5 to the power 3. Then q equal 5 to the power y. No? 5 to the power y equal 5 to the power 3. Then say y equal 3. Then say y equal 3. That is one solution. So anyway, you have to identify that simultaneous equation. You have to identify that simultaneous equation. Then further you can simplify. Further you can go further. Okay. Let's move. Then we know P now. Sorry, we know Q. Here it is 125. Then by this one find P. P equal Q plus 3. Q mean 125 plus 3. 128. Then 2 to the power x equals 128. That is 2 to the power 7. Then x equals 7. That's how we solve the simultaneous equation. So these equations we have to think a lot, okay? We have to think a lot. We have to do substitution. We have to think about exponentials. We have to think about simultaneous equation. And many things we have to think. That is question number 6. Complete. Okay. Now let's move to question number 5. Let's move to question number 5. See this? Log a base n equal x, log c base n equal y. Then here we have x minus y over x plus y left hand side. Then log a base n, log c base n, log a base n, log c base n. But here now you get common denominator. Let downstairs 1 over log n base a, 1 over log n base c, 1 over log n base a, 1 over log n base c. Then get common denominator. Here this goes to here log n base c minus log n base a. So this goes to here log n base a log n base c. Okay. Then when you get common denominator here, that denominator and here denominator we can cancel, no? We can cancel. Then here this one and this will be there. But here no n base, no? We don't have n base. But here we have b base. We have b base. Then you can write here. You can write log division log c divided by log n. Put common base b. Here for this log a log n. Put b base. Here log a log n. Put common base b. So like that you can write, no? Here this log you can write as division with common base. C upstairs, n downstairs. Then this common base we can log value we can cancel. Then log b base c, log b base a, log b base a, log b base c. Now that equal right hand side. Complete. Okay. Now, question number 7. Question number 7. If you have a problem, just ask me. Question number 7. 1 minus 4 over 3 to the power n. 1 minus 3 over, here 3 over 4. 4 to the power n equal 0.28. Then you better take 3 to the power 4 and take x. Then 1 minus x, here 1 plus x, 0.2x. First you take this one x, then simplify 0.28x. Then take one side, 1 minus 0.28 x plus 0.28x. Then here 0.72. Here 1.28x. Then x equals 72 over 128. 72 over 128. Further simplify. X equal, here this is divisible by 4, no? 72 over 128. Just divide by 4. Here 132. 9. Here 3, 2. Okay, no? Zero 0.72 over 128. Okay, then this is divisible by 4. Then here 132. Yeah, 18, no? 18. Then 9 over 16. 9 over 16. 3 over 4 squared. Then x mean 3 over 4 to the power n. Then equate indices n equal to. N equal to. These questions are simple, but you have to think some small simplification things. Okay. Then last one, let's do question number 1. Let's do question number 1. See, x, y plus z minus x over log a base x equal log y z plus x minus y over log a base y equal log z times x plus y minus z over log a base c. Let's take t. So when we have two equal signs, we better to put another equal sign with t. Now equate these two. Log a base x. Then again you divide by t. Say 1. Then do same thing here for this. Y z plus x minus y here over t log a base y. Second one. So I'm going to simplify only one term. We need x to the power y and y to the power x. We need x to the power y and y to the power x. Here, 1 multiplied by y, 2 multiplied by x, and add it. Then here, xy, y plus z minus x over t. Here multiply by x, y x, z plus x minus y over t. Here x log a base x. Here y log a base y. This is special question, okay? So you better to practice these questions again and again. You better practice these questions again and again. Then when you see this, here xy over t common, then you can cancel y, you can cancel x, then xyz, then 2xyz over t. Then here x to the power x, here this is y, no? This is x. Then here log a base x to the power x to the power y times y to the power x. Here addition like product, no? Y to the power x. See, here 2xyz over t, log a base x to the power y, y to the power x. Similarly, you can write the other two. And similarly, no need to simplify. So one simplification had done, no? Then no need to write all. Then similarly, you write the other two equal with this. 2xy z over t equal log a base y to the power z, z to the power x equal log a base z to the power x to the power z. Likewise, you write. You take one, similar like the other two. Now here these three same. Here these three same, no? Then you write, therefore, log a base x to the power y to the power x, log a base y to the power z, z to the power x equal log a base z to the power x to the power z, same. Then cancel logarithm. Likewise, you can obtain. Okay. Then this is again special simplification. So these things you have to practice again and again. You have to practice again and again. Complete. Okay. So today I discussed a worksheet that belongs to functions and logarithms. Then there are many special questions in that worksheet. You do same questions again and again and practice it well. Okay. If you have any doubt, drop me a message, then I can guide you how to do that one. Okay. I think that's enough for today. That's enough for today.